Okay, ladies and gentlemen, time ticks on, and I want to briefly talk about subtyping, and I want to do so with, again, a very pragmatic goal in mind. I want you to feel comfortable with doing common things in AnyLogic. My goal here is not to give you a key sort of understanding conceptually of what typing is and the benefits it brings to programs, but rather to prepare you to work with AnyLogic code and not be thrown off by certain types of features. Okay. We just talked about functional abstraction, and I had mentioned before this notion of a class as a mold in which we can use to cast many particular objects, or so-called instances of a class. So we have a person class that describes personhood or personness, and we can create many particular instances of it, many, as we say, objects. Okay, it turns out that that classes provide some service interface, some way that we can request things, and implements details of that. So we might have a main class, a person class, and a simulation class, for example. And we'll manipulate them by reading fields or setting fields, like reading someone's age or setting their income, calling methods on them, and creating objects. Okay. These are good things. Okay. I'm skipping things that I don't consider absolutely essential here. These are great things. They're things of beauty. But I want to talk about when we have types. When we have types like a class, or something called an interface, which sort of says, I have these services I can offer. You have to give me this, I'll give you back these services. When we have that, we'll sometimes have relationships between them that are familiar in their broad form from things we see in the external world. So look, when we're dealing with things in the external world, we deal not exclusively, but much time in terms of taxonomies, of hierarchies. So we'll have, for example, animals, and animals are divided into several different subfamilies, including mammals, and within mammals you'll have, a set of different things, including primates, and within primates you'll have great apes and lesser apes, or what have you, and monkeys. So we have these hierarchies, and there we can say that, okay, a chimpanzee is a great ape, which is also an ape, which is also a primate, which is also a mammal, which is also an animal, right? So we have these hierarchies. Or let's talk about medical hierarchy. You might have a spinal orthopedist who's an orthopedist, who's also a surgeon, who's further a type of medical specialist who is an MD. We have this specialization hierarchy. And if they ask on a plane, if they announce, is there a doctor on a plane because we're having a medical emergency, a spinal orthopedist could come forward and say, yeah, I'm a doctor, right? So in our reasoning in the world, all the time we deal with these hierarchies of specialization. Cheryl and I can both serve on the faculty council. We're both faculty members, even though she's a faculty member in one college, I'm in another. We share that characteristic. Both of us, by virtue of being employees of the university, have recourse to other types of information. We have access to certain certain types of information systems or access to the pensions office or what have you. Okay, so it is with computers. We have this way of capturing these hierarchies of specialization. And we call that subtyping, okay? So just like a banana is a fruit, which is a biologic structure. I don't know what to call it. So it is we have these subtypes. So we might have in our model that a person is an agent, for example, which is an active object of some sort or another. And there's some special rules about this. You can't, if it claims to be an agent, it has to live by the rules of the agent, so it doesn't have any behavior that's surprising for someone who knows only about agent code. But in AnyLogic, we'll have several types of agents, and all of them qualify as being agents, and they could be connected to each other as agents. Okay. Right. So let's talk about this. So if we were to let's talk about a practical implication of this. Let's go up to one of the models we built. Let's go to this one. Here we go. Let's go to person. And let's go up in person to connections here. Okay. Here's connections. You'll notice that within connections, I can specify to whom I'm connected. Notice this says to any agent. What that would mean is if in my model I had deer and I had dogs and I had horses and I had people, a person could be connected to any of those. If I change this to say, no, wait a minute, they have to be a person, now they can only be connected to other people, okay, with this. Any person is an agent. If we had left that as agent, could they be connected to the person? Yeah. But some of the things they could be connected with, the horse, are not a person. So persons, if there were a horse class in the model, a class for deer, those would all be agents. And sometimes a person might want to send a message to an agent. Say like, yeah, to their dog, right? This is my pup. I want to send it a message saying, go outside or something like that. And come here, go fetch, right? So we do have times where a person wants to deal with any sort of agent, or other times where it wants to deal with a particular type of agent. So this is one place you see this. I'll show you another place. We created a model, which you may remember. It involved, it was the SIR model. I may have it open here. It's not that one. It's the GIS one. Remember that? Here we are. The GIS model version 5. Do you remember that we had a clinic and people could flow through the clinic? Do you remember that? Yeah. So it turns out that if we went to the clinic here, let's go to the clinic. Here we go. So let's take a look at the treat block. Okay. So here they treated the agent. Okay. Now you may notice it's not immediately obvious, but down here in advanced, it says agent type agent. It's just dealing with this person that's coming through, and it's assuredly a person. There ain't no deer going to this clinic, okay, presenting for care. Here, it's just dealing with them, though, as an agent. And what that would mean is it would be problematic if we tried to access something that's specific to persons. Let's suppose we want to ask for their income. Gosh, this would not be good. But if we were a model in the US, it would be highly relevant, perhaps. We want to know what's their income. Or do they have an insurance? Do they have insurance? If we want to ask that, we couldn't do that for any old agent. It would have to know they're a person to be able to say, do they have insurance? Because not all agents know how to do that. The horse, the bunny, they don't know how to answer if they have insurance or not. And particularly if we want to take advantage of any of these things in person, any of these sort of parameters we have, what their home is or what their workplace or whatever, if we wanted to take advantage of that information, we'd have to know they're a person. And right now that wouldn't be available. If we said, Trace LN, even my age, but my home is, home. All right? And we were to run this here, bad things would happen. Because it won't even get out of compile phase, I think. Yeah, see, it's unhappy. Why is it unhappy? Why is it unhappy? Watch this. Home cannot be... let's get rid of this search nonsense. I want to see problems view. Here it is. Problem. Boom. Here it is. Home cannot be resolved to a variable. You may say, well, wait a minute. I'm just asking for their home. I mean, every person has a home, and you see it's saying, well, I don't know where home is, and I might say, well, agent.home. Okay, fair enough. Agent.home. There we go. By the way, the name of the person flowing through is agent. So if I said, well, okay, it's agent's home, right? After all, it's going to say home cannot be resolved or is not a field. And you might say, well, wait a minute, it is a field. I mean, it's a field of the person, and the agent is a person. But it doesn't know the agent is a person. It just knows it's dealing with it as an agent. It would be kind of like if Cheryl went to the emergency department, they don't know that she's a prof of veterinary medicine. And so they just deal with her like any old patient, and they might not even ask her for her. I mean, this is a bad example, but they might not ask her for her, USASC identification information or what have you. But then if they find out, oh, actually she's a U of S employee, maybe there's workplace compensation issues or something, they might ask for this added information about her employee ID number because they want to record it. I had a workplace injury here, and they want to know a little bit more. The point is that right now it's dealing with it as an agent, because any person is an agent, ladies and gentlemen. But if we want to restrict it to person, we would just say everyone coming through here is a person, okay? You can actually do that to each block here. And now, with my clarification that they're a person, it's a happy camper. Perfectly happy. Why? Because persons have a home. They have a home. So if we were to run this now, it would happily print out for each person who was treated what their home is. We could easily have it print out what their birthday is or whatever. Animals have birthdays. What their first language is or whatever. See, you'd say my home is such and such, because it knows that they're a person. So the issue is not, in many cases, what they truly are. It's does it know that they're a person? And here it's dealing with them in their capacity as just an agent. If we want it to deal with them in their capacity as a person, we have to realize that sometimes we have to look beyond its default way of dealing with them as an agent and know, oh, they are a person. They're a specific subtype of agent. So we have these specialization hierarchies here, just like we do in real life, so we can have in our model. And this can be very useful because it allows us to write some things, some code, some functions, some specialized machinery up here, for example, for persons that will handle any of these others. Any of these others could be handled by this by machinery that treats them as persons. We could handle automatically all of these folks. Now, if these folks have some specific needs, then I may have functionality which has to be written for them specifically. But this allows us to reuse a lot of mechanism, because once we dealt with something for persons, it can be reused for doctors, for nurses, for chiropractors, for radiologists, orthopedic surgeons, all those sorts of things. It can be reused as such, which gives us great affordability, great benefits. So I suppose like an example would be if there were a model of, West Nile virus, which included horses as agents and people as agents, we might have certain mechanisms that take the time from infection to clinical presentation of symptoms or something like that. And that might be something that could be computed in common for both of them or something along those lines. The point is that we can do things once for a whole set of things. Okay. So in AnyLogic, we might have agent as a superclass, and then we'll have multiple types of agents here. More than that, we might find, for example, that persons here, we want to actually divide it into women and men as agents, and we can reuse the same basic mechanisms for each. Let me give you an example of this. In the code that we gave you, there was a model. There was a model which is called Hpv Model or something like that. This model has a measure of antiquity, but currency even yet. It was created by a great student a number of years back who Cheryl and I both admired, and I'm still going through withdrawal from her not being here, Karen Yee. And basically this involved a situation where we had persons, but we have males and females as subtypes of persons. What that means is anything that is in person also applies to the subtypes. So we can describe some things here for person, like there's having a smoking status, having a sexual activity group to which they go to, having an age, member of different age groups. All of these are in common for personhood, whether you're male or female, you have all of this. But meanwhile, males have some additional characteristics that's unique to males. So there's a certain set of sort of natural history of infection with respect to HPV. You'll notice in the background here, can you see it? In the background, there's all the characteristics they have as people. But then males have these extra characteristics here. And these are characteristics unique to males. For females, we have a much broader set of characteristics with respect to HPV because it involves progression to possible cervical cancer, etc. So here for females, we have all the human characteristics. See back there, their smoking status. See back there, their sexual activity groups, etc. But then there's all this progression into different risks of cervical cancer and, and early stages and screening features. The key point is when we describe males and when we describe females, we don't have to re-implement, the common characteristics of persons. We describe that once, common characteristics of personhood, and then for males and females, we do what's called we inherit from it. Okay? So you'll notice that here for female, in this, under advanced, it says this person extends this other agent. It extends person, meaning it's a subtype of person. All the characteristics that are true of persons are also true of women, but they have extra characteristics. Same thing with men. All the characteristics they share in common as humans, as persons, are there, but they have these extra characteristics that they carry around that are distinctive. And so it is that AnyLogic allows us to do it. It could say extend other agents. And it means we don't have to go and re-implement it every time, and if there's a mistake, we have to fix it in both, and if we want to modify it, we have to modify it in both. We can make use of the same statistics over the population, the same state charts, the same functions. All of that's in common, and we just need to focus on the distinct characteristics.
Okay, question with that.
Yeah.
So first, I understand you have your population in Maine just as you normally would. What about the subtypes, the male and female?
Yeah.
Can you have a population
Of
of
female,
males
yes, you
or
can.
males?
Yeah.
And that
Yeah.
would live in Maine?
Yeah.
Or that lives in
It can live in Maine, yeah. Yeah, so there's actually a couple ways you can do this. Here we have a common population, but the people put into it, some of them are men and some are women. Or you could have two separate populations.
Could you have all three, or that just wouldn't make sense?
Sorry, all...
Like
Oh, yeah.
male, female, and for separate statistics? Or is that going to cause
It's going to cause problems. Yeah, it's going to cause problems.
Okay, so
Yeah.
one way or the other.
One way or the other, you could do it. Yeah, and so you could have one that this population is mixture, or this other one you have two separate populations, so you have separate statistics. But it affords this sort of clarity of understanding of some things which are person level and some things that are agent level. Now, AnyLogic, for a number of years, including in Karen Yee's time, this was incompletely supported. It was kind of something you can do, but you needed to be quite virtuoso to do it. These days, it's very straightforward, and it's very powerful. It's a very powerful concept, particularly if you have multiple hierarchies. So if you have things in common, another example might be. Again, think of West Nile. If you have persons and you have horses, maybe they would have in common a general natural history of infection, but they differ in the parameter values, the timings with which they progress. You could easily capture that. And then you wouldn't have to, for humans, capture those as a completely separate state chart than for horses. They just differ in degree.
So where would you put that state chart then if it was?
You would have a common state chart in something like mammal or host or dead end host, something like that. One of the you wouldn't have to do that. I mean, there's actually some rules of thumb that come up when you're doing this in software engineering. There's a question of when do you need a separate class? When do you reuse the same one? And one of the foremost principles are, does it differ in behavior or only differ in sort of degree and detailed data? If it's detailed data, use the same class. If it's very different behavior, like, let's check out females here. They have very different behavior from males. A fact which has probably not escaped all of us. Here's females, and males is much less textured. So here it makes sense that males and females be different classes. But there's the further prospect here with subtyping. So, you could have this model and not have person, just have male and female. The disadvantage is that you would be re-implementing in both of them at some risk, potentially, and some tedium, all this sort of mechanism. And you need separate statistics that operated in the version for men and the version for women. Do you have them as persons? you can reuse a lot of the same basic mechanism. But that requires subtyping, and it's close cousin, but more involved actually, subclassing. And this is actually using what's called subclassing, where it's actually reusing both sort of the promises and the implementation. So this is extending that other agent, and you can see it behind there. It's kind of layered on. And it's a powerful notion, and it is one that AnyLogic supports, and in the right circumstances, it's very valuable. So if you had a hierarchy of doctors, clinicians, allied health professionals, or a hierarchy of animals, or what have you, you want to simulate, you might do very well by making reuse of these mechanisms. This, like functions, is another way to reuse mechanism. It's reused a lot across a lot of subclasses. Again, you have one place you go to fix the smoking state chart, not many, many places. Okay? And something that operates on a person, you could pass it a female and it'll be fine. You could pass it a male, it will be fine. But there'll be some things that you have to be male to do, or some things that you have to be female to do. Yeah. Okay. Right. Turns out that this is all around. AnyLogic, if you go and you poke around, you'll find lots of things. So you have transition timeout, which is a subtype of transition, or transition condition, subtype of transition. I never explicitly use these things, but the model is built out of them. And even, I don't know if you'd remember, but when we saw that console message before, it mentioned something about transition timeout or something. That's just a subtype of timeout. And in Java, you have lots of these things. So you have an array list, which is a list, which is a collection, which is an interval. And anything that operates on a collection can operate on an array list, therefore. I heard someone over here talk about hash maps, and a hash map is a map, and anything that operates on maps can operate on hash maps. So in Java, if you're going to be kind of writing a bit of code, it's worthwhile knowing about these things, because you could have something that processes sets, and you can give it a linked hash set, and it's fine. It's a happy camper. Yeah, and there's lots of these things in Java. Okay. I'm not going to talk about this. Yeah. Here's a model which is multiple types of things, multiple agent classes in the same network. So I could be a square, and you could be a triangle, and I'm connected to you in the network. Similar sort of idea. Okay. Yeah, and I give some directions for creating. This is an older version of AnyLogic. I've got to make sure this works, but I'm pretty sure that it still works here. Yeah. Yeah. Good. Anyway, a lot more that could be said about these things. In my software engineering classes, I'll go on for several lectures about Liskov substitution principle and the extra subtleties associated with subclassing and how to use both safely and the extra considerations computer scientists need to bring to bear. I don't see that as fundamentally enabling for your work. What I do see as enabling is this level of coverage, so you're aware subclassing is possible, so you can have subclasses of another class, like male of person or female of person, and so that you know that every person is an agent, and that you know that if you've got something that's only designated as an agent and you try to treat it as a person, you may well encounter a problem. It will say, I don't know how to treat it. Oh, a final comment there. If you are ever, this used to happen a lot, but AnyLogic cleaned it up version 7, for version 7, but it occasionally comes out. Occasionally you will ask for, do you remember this thing like get connected agent? Do you remember that?
Yep.
Okay, watch this. Yeah, maybe I'll go here. Maybe I'll go actually here. I got to remember not to save. It's very hard for me to do. Okay, suppose I said this dot get connected agent, okay? Get connected agent. They didn't fix it entirely. See this get connected agent? What does it return? It takes an int as an argument. What does this return? An agent, ladies and gentlemen. Does it return a person? No. So if I said get connected agent 0, the first one to whom I'm connected, I could send them a message because any agent can receive a message. But suppose I wanted to know their home. I want to say my neighbors, my connections home is such and such. I want to ask for their home. It's going to be an unhappy camper. Why is it going to be unhappy? Watch this. Why is it going to be unhappy with this? Look at that. Do you recognize that message? Double click here. Recognize that message? Why is it unhappy? Because we're asking for the home of a what? Here, let me show you again the.
Asking for the home of a person, right?
Well, we know it's a person.
Yeah.
We know it's a person. But watch this. Oh my gosh. Oh man. Come on. Okay. Dot get connect. Here. Connected agent. What is it? We know it's a person because we know everyone's connected. Every person is only connected to a person. There's no dogs in the model. There's no deer in the model. We know everyone's connected to a person. Does AnyLogic know that? No, it just knows we're connected to an agent. So suppose you're in this situation. You're wedged. You can't. All you get back is an agent. There's an easy solution, but this is why I'm telling you about it because all persons are agents. It just does not smart enough to know that they're a person.
Oh, yes.
Now, so it's not smart enough. So what we have to do here is quite simple. Fear not. All we do, but this is something that, if you show someone who's not a computer science, you know how to do that. I'd be really impressed. Because even computer science students get stuck on this sometime. They get stuck. They engage in flailing behavior in the labs. Okay? This is what you have to do. So this is an agent. It doesn't know it's a person. If we tried to say person P equals this, it's also going to be unhappy. It's going to say, I don't know, it's an agent. I don't know, it's a person. I saved it. Okay. If I said this, it's getting closer. I want to say, this is a person. It's a person here. Believe me, it's a person. And it's going to say, I don't know, it's a person. Oh, index. Here. Oh man, I'm screwing this model up. It's going to say, I don't know, it's a person. I don't know, it's a person. It's going to say, cannot convert from agent to person. And you say, well, wait a minute, I know it's a person. It's saying, tell me. You want to take responsibility for that? And the way you say, yeah, I know, and I'm informed, it just doesn't let you do it, kind of fall into it. If you want it to treat it as a person, you want to take responsibility for being a person, which in this case is perfectly safe because there ain't no other sort of agents around. What do? You do one of two things. The thing that's a little bit more computationally impressive from the standpoint of code, you just say, remember casting? Do you remember type coercion? You go like that, and it'll say, yes, ma'am. You want to convert this to a person? I'll do so. You're taking responsibility if it can't be, but I'll do it for you. That's one thing. But the other thing you do, ladies and gentlemen, is sweet. And AnyLogic only inserted it in AnyLogic 7. And it's one of the reasons why we're careful about it. May I show you? Can I show you? So this works. It works perfectly fine. You will occasionally need it. You cast it to a person. It's called downcasting. Not as in downcast eyes, but as in taking something that's further up in a hierarchy, an agent, and converting it to something that's lower down, a person. Man, there's not many non-computer scientists that know about this. So you should feel proud. Okay? But watch this. I just got rid of this person thing. The solution there was perfectly fine. This worked fine. But there's a better way to do it in the sense that it will eliminate the objection in the first place. So I'm going to put this back, and it's going to be unhappy. Do you see this? It's unhappy. See that? And I'm going to even, just to sort of bring home the beauty of the new solution, I'm going to even put it back in its form like this. Remember this? It was unhappy because it said, I got the neighbor, and it's an agent, it's not a person. And it's going to be unhappy. Do you see it? Do you see its displeasure shown? Or is it behind my head? Do you see the displeasure? Well, at least you heard the sound of it, too. Okay, so this is the way you fix it. You want to see this? This is nice. Most AnyLogic users won't know about this. I think this should work. You want to see? So what you do, where is this? I'm playing with two little. Hey, come on, give me the. There it is. See this? Where is it getting the connected agent? Whence is that coming from? What is it asking to get it? Do you remember? Up here, there's connections. Do you remember that? There's this connections thing, and I said that's the thing used by default, unless you explicitly specify, like use it from the IDU connections, use it from the needle sharing, the sexual connections, or use it from the family connections. Use it from here, okay? Oh, a beautiful idea crushed by an ugly fact. So I actually thought that you selecting this with person would let it know, and that it would actually automagically do this. Alas, that's not the case. Oh, were it only so. I thought they fixed this so that when you did this, it would, instead of agent, it would actually know to convert it. Oh, okay, I'm getting it from connections. Therefore, it knows to do it. Let me check this. Don't write it off quite yet. We have another. No, okay. So watch this. Where was that I was doing that? Was it? Oh, it was here. Yeah, here it was. Okay, watch this.
Tell it about connections.
Yes, I think if you say this dot connections. Okay, let's see if that works. Right, I'm pretty sure you ask the connections, and it says, oh, you're going through connections. Oh, you're connected only with people. Sweet, done. See, it's explicitly going through connections, and it looks at connections. See, it says, what do connections connect to? They connect to person. Oh, they connect to person. So the thing I'm going to get back from getConnectedAgent is a person. Now that, ladies and gentlemen, that has an extra degree of generality. So it's another reason to pay attention and change it. If it's going to be connected to a very specific sort of animal or agent, you want to select it. If this is your dog connection for a service dog, you change it to be dog for the agent type that you're connected to.
Good way to do it if you've got more than one set of connections, just to be really specific about which network you're connected to.
That's right. That's right. These are my horses. These are my dogs. These are my whatever. Yeah. Okay. Okay. Some practical tips involving subtyping as it applies to AnyLogic. Thank you very much. It is past 7 o'clock. It's been a long day and a long week. And tonight I will try to sleep so that I can be in here bright and early tomorrow morning and start helping more with some of the projects. Thank you for your patience.
Is the general plan for tomorrow 9 o'clock sort of starting time?